So the first system, 5x minus 3y is 7. Negative 5x plus 3y is equal to 1. If we add vertically, negative 5x and positive 5x cancel because 5x minus 5x is 0. And negative 3y plus 3y is 0. So you get 0 equals 8. Does 0 equal 8? No. So because 0 does not equal 8, what does that mean about the system? It means that there is no solution. You can either write no solution or you can write the null set. And that is the answer in this case. Well, what kind of system would it be if the lines don't intersect? It would be a system where the lines are parallel. So there's no solution for this system because if we were to use the graphing method, these lines would be parallel. Okay. Now, the second system, 4x minus 3y is 6, 8x minus 6y is 12. If we add vertically, no variable cancels. However, we can make a variable cancel because the least common multiple between 4 and 8 is 8. LCM of 8. Now, this coefficient is already 8. So if I want these variables to cancel, we would have to multiply 4 by negative 2, which would result in a negative 8. So I'm going to take the top equation and multiply both sides by negative 2. And notice how I multiplied both sides by negative 2. I used parentheses to be certain that all three terms are going to be multiplied by negative 2. Now the result of that is negative 2 by 4x is negative 8x. Negative 2 times negative 3y is a positive 6y. And 6 times negative 2 is negative 12. Now I'm going to write the other equation from the system. 8x minus 6y is 12. Now you can see this is another one with strange results because when you add negative 8 and 8, they cancel and you get 0. Negative 6y, positive 6y cancels and you get 0. And negative 12 plus 12 is 0. So now does 0 equal 0? Yes, it does. So what does that mean about this solution? Well, it means that there is an infinite number of solutions. Now, that's not the answer because that doesn't tell us what the solution is. It just says that there are a bunch of solutions. But you would, if we were graphing, we would graph one line and then we would graph the other line and the lines would be right on top of each other. So if we want to state the solution, all we need to do is write the equation of the line. So any ordered pair such that, and then I'm going to write the equation of the line, 8x minus 6y is 12. And all four of these equations are the same, so it doesn't matter which one of those you write. But there's an infinite number of solutions, and then you need to name the solution as a point in this line, because obviously this point right there is not a solution. Only the points on that line are solutions. Okay, so we're going to do one more example. And in this example, we're going to look at this system. X plus 2y equals negative 1. 4x minus 5y is 37. Now bring it up. 1 second here. 3x plus 2y equals negative 1. And 4x minus 5y equals 37. Okay, so you can see that if we add vertically, no variable is going to cancel. So every problem you do, you have two options. One option is to try to eliminate x. The other option is to try to eliminate y. So in the margin, I'd like to talk about our two options before we actually do any eliminating. So for x, there is no number I can multiply 3 by that's an integer that would allow me to cancel with 4. So we're going to have to multiply both equations by a value. So the LCD, or the least common multiple, between 3 and 4 is 12. So in order to use the addition method or the elimination method, we're going to have to multiply the top by 4 and the bottom by -3, so that the signs are opposite. Okay, so that's one option. Our other option is going to be to eliminate y. So for y, the LCM between 2 and 5 would be 10. There is no whole number or integer I can multiply 2 by to cancel with 5. So we're going to have to adjust both equations if we choose to eliminate y. So we would have to multiply the top by 5 and the bottom by 2. Because the signs are already opposites, we won't have to go any further on that. So neither one of these is that much more compelling than the other. 12 and 10 are both pretty similar. So I'm going to eliminate x. So I'm going to multiply the top equation by 4 and the bottom equation by -3. So top equation by 4 and the bottom equation by -3. And notice I'm going to rewrite the whole system. So the system becomes 12x plus 8y is -4. -12x, when I multiply two negatives, I get a positive 15y, is, when I multiply 37 by 3, I get -111. Now we're going to add vertically. -12x and positive 12x will cancel the way we expected them to. 8y and 15y is 23y. And -4 and -111, the signs are the same, so you add and get -115. Now to finish solving for y, we're going to divide both sides by 23. And you're going to have y is -5. Are we done? No, because now we have to go back and find x. Now we can use any one of these 4 equations. I'm just going to use the top one. 3x plus 2y is -1. And I'm going to make my substitution for y right there. So that'll be 3x plus 2 times -5 is -1. So 3x minus 10 is -1. The inverse of subtraction is addition. 3x is 9. Divide both sides by 3, and you'll get x is 3. So your solution for the system is 3, -5.